Hi guys, I got some kinesthetic vocabulary for you for our upcoming chemistry unit, and it incorporates some review aspects. It also incorporates a lot of the new content and vocabulary that we'll be talking about. I will admit this is the longest kinesthetic vocabulary that I have, but it is my favorite. And again, please keep in mind, you gotta buy into it or else it's not gonna work for you. You've gotta make sure that you're doing those hand gestures, saying those words, saying them with conviction, like a purpose, like you want to learn them and remember them. And so feel free to have a little bit of fun with it. If you want to do it with an accent or whatever you need to kind of help you add a little bit of fun, add a little bit of emotion to it to help you remember these vocabulary words. Well, this one is for chemistry. And just like the other ones, I'm going to try and run through it once, run through the descriptions, and then run through it 2 or 3 more times, just to give you a chance to kind of practice it. Feel free to come back to the video anytime you need to kind of help give you a refresher, give you a safe place to practice. I won't laugh at you, I won't judge. And feel free to use this vocabulary during class, during discussions, on tests, while you're walking down the street, talking to strangers, and teaching them about science. You can feel free to practice it. So here we go. A man named Mendeleev developed a periodic table. It has 3 parts. There are metals on the left, non-metals on the right, and metalloids along the middle that have properties of both. Elements are represented in a box. It includes the atomic number, the symbol, and the atomic mass. The mass of the atom is found inside the nucleus. It contains protons, neutrons, and electrons in the cloud. Electrons follow the 2-8-8 rule. Elements in the same group have the same number of valence electrons. Element in the same period have the same number of shells. Okay, I know it seems like a lot, but we can break it down. We're going to go through it in chunks, and you keep practicing, and I know you'll get it. First off, we got to know who developed the periodic table. And so that's a man named Dmitri Mendeleev. And so what I use for that gesture, I just have 3 fingers, and I just fold them over my thumb, and this is an M in sign language. So his name is Mendeleev. And the 2 fingers for V, so Mendeleev. Well, he developed these 3 different sections, so I use my other hand, and I make sure that everyone in the audience that I'm doing this towards knows that it has 3 sections. So again, say it with purpose. And of course, I know you know those 3 sections, so this is a great time to review those. We've got metals on the left, and so on the left side of your body, I just take my fist and pound it against my hand. This is just like that property of metals, which is malleability. They can be pounded into shape. On the left side, we've got nonmetals. They're kind of crumbly. They're kind of gaseous. So I just kind of twiddle my hands a little bit and make sure I cross my body, and I've got metals on the left. And then, well, of course, we've got those metalloids. So they have properties of metals and nonmetals. So we've got properties of both, and they are along the stair step. So we've got metals on the left, non-metals on the right, and metalloids along the middle that have properties of both. Well, on that periodic table, we also need to remember the parts. So elements are represented with information in a box on that periodic table. That top number is typically the atomic number. And so another hint that we'll come back to later, I want you to kind of make 2s. Spread your fingers apart really wide and then stick your thumb in between. So give me 2 of those. These are P's in sign language. So that number on top, just like your face is your identity, it's how I know who you are. And for elements, that atomic number, that number at the top of the box, is the number of protons, and it's the identity of the element. Of course, in the middle, just like Superman had his symbol on his chest, in the middle of his body, elements have that atomic symbol in the middle, so I usually put my hands on my hips and stick my shoulders back and say symbol. And then finally, we've got the atomic mass. Not the same as atomic weight, but I do stomp my feet. So again, wanting to have that purpose and emotion. And atomic mass. So here we go. Elements are represented in a box. It includes the atomic number, the symbol, and the atomic mass. The next portion kind of breaks down the atomic structure. And so we start with our fist. You can use any fist you want, left or right. And your fist is dense and tightly packed. That's just like the nucleus of an atom. So we say the mass of the atom is found inside the nucleus. And I usually shake my fist because I want to make sure people know it. So I say the mass of the atom is found inside the nucleus. And then I'll go back to that P, those protons, which is the same as the atomic number, and I'll just kind of tap it. Because these protons are located inside the nucleus. Also, inside the nucleus, as you'll be learning if you don't already know, are neutrons. And so for an N, I just put up 2 fingers and fold them over my thumb, and I just do the same thing, I tap it. N for neutrons. So protons and neutrons are contained inside the nucleus. Finally, that third subatomic particle are electrons. So I'm going to represent that with an E. And they're not found inside the nucleus, they're found around. So I'm going to circle my hand around that dense nucleus for electrons when I say electrons. And hopefully that's going to help you remember those 3 subatomic particles. We've also got those electron shells. And those follow the 288 rule. So we've got up to 2 valence electrons that go in the first shell that's closest to the nucleus. So you'll notice I make a 2 right here close to my wrist. And then the rest follow the 8-8 rule. And so I just tap 2 more times for that second layer and that third layer of electrons. So we'll start that segment over again. Here we go. The mass of the atom is found inside the nucleus. It contains protons, neutrons, and electrons in the cloud. Electrons follow the 288 rule. Good. Next part talks about groups and periods. So we're just going to talk about those. Elements in the same group. So we're going to move our hands just like groups on the periodic table. Elements in the same group have the same number of valence electrons. And then elements in the same period, just swipe your hands side to side, have the same number of shells. And so I just use my hand to make those shells. And that's it. Feel free to add more. I would love to hear about what you add and how you change and modify it. Feel free to let me know how you modified it. But I am going to run through it 2 more times so you guys can practice. Here we go. A man named Mendeleev developed a periodic table. It has 3 parts. There are metals on the left, non-metals on the right, and metalloids along the middle that have properties of both. Elements are represented in a box. It contains protons, symbol, and the atomic mass. The mass of the atom is found inside the nucleus. It contains protons, neutrons, and electrons in the cloud. Electrons follow the 288 rule. Elements in the same group have the same number of valence electrons. Elements in the same period have the same number of shells. You may have noticed, I talked about this being protons instead of atomic number. Again, feel free to change it and modify it. Whatever's going to help you remember those different parts is what's important. But here we go one more time. A man named Mendeleev developed a periodic table. It has 3 parts. There are metals on the left, non-metals on the right, and metalloids along the middle that have properties of both. Elements are represented in a box. It contains the atomic number, the symbol, and the atomic mass. The mass of the atom is found inside the nucleus. It contains protons, neutrons, and electrons in the cloud. Electrons follow the 288 rule. Elements in the same group have the same number of valence electrons. Elements in the same period have the same number of shells. We got one more time. A man named Mendeleev developed the periodic table. It has 3 parts. There are metals on the left, non-metals on the right, and metalloids along the middle that have properties of both. Elements are represented in a box. The atomic number, the symbol, and the atomic mass. The mass of the atom is found inside the nucleus. It contains protons, neutrons, and electrons in the cloud. Electrons follow the 288 rule. Elements in the same group have the same number of valence electrons. Elements in the same period have the same number of shells. I know it's a lot of vocabulary, but I know if you keep trying, you're going to get it. So keep practicing and let me know how it goes.